morning, everyone. So my name is Keshav. I'm from third year at MIT. Currently pursuing the Samsung AI course. So I have stated a problem statement where fine-grained FGVC, like fine-grained evacuation system, like see here, yeah, fine-grained visual categorization. So most of the models are like, for example, we can distinguish between dog and cat, but the birds, like their beak, the bird feather, is very distinctive and very fine. So I made a model where such distinction can be made using this algorithm, fine grained visualization, FGVC. So for example, we start with that. Then the model is 4248, like not like normal model are like 2424 resolution, but my model is like high resolution, 448 cross 448 resolution. And then we go for like my class is not like other models. It has a 200 classes. Each bird are divided one by one in one class. We can't conjugate all of them in like tropical or any methodical or something like that. So there are 200 classes for each bird, one class. So it gives around test accuracy around 97.91 and the training accuracy is around 90.20. So this is so then we go for like I have made a structured front-end AI I use Gemini Flash 3.5 or 3.6 for a structured methodical format answer. For that, because most of the AI model, if we don't use AI services, it gives a messy, vague answers. Like you don't get a proper answer, a proper formatted what you want, what the user wants. So then we go for the full system architect. So here, what I have done with the Kaggle offline GPU, I haven't used my own GPU like 4060 Ti. I've used the offline training GPU given by Kaggle. So here, this is the main training part. Here we are like taking the dataset CBU 2021. It has 200 classes of the North American birds. Then we go for processing, and I have used the main core part as EVA02 based backbone model, because before I have used efficient DBNet, but it gives around 65 to 75 accuracy at most with 1024 or 1024 resolution. But EVA02 is much more easier. It gives with 448 and 440 resolution. It gives around 90, I'll show you 90.20 accuracy. And then we use PyTorch for training model using, and we get 11,543 correct out of 12,000. 11,798. So we get the bird width PTH. I've shown you before. Bird width PTH here. I've used it here in the training model. PyTorch model, EVA02 Python, and here I have used TensorFlow. You can see here all the imported parts. Then we go for main part, load model application, how we use the weight in the main model part. Then we use, here I have defined a class, major class is bird inference engine. There we use the main preprocess EVA02 transformer, then the in class index, then taxonomy. I will show you after the demo, in the demo how I have used this taxonomy lookup engine. Then we go for the genetics of species, how we differentiate each bird by genetics. Then we go for fast API. I have used Unicorn instead of instead of AWS or Azure or any cloudware or Docker. I've used Unicorn. It's much easier. It can be like depicted by your hand normal ways, just 2 or 3 tweaks. And then we go for generative ecological system. I've used Gemini 3.0 Flash here because for this Gemini ecological system. So this intelligence helps you to understand each and every part of the bird, like what is his genetics, how he has made. So I've used here 3.5, 3.6 Flash. Then we go for like what are the model specifications. For example, I have used the EVA2 zero batch for, I told you EVA2 base batch for the core part. And then this is the input image resolution 440. There are like classes at 200. So normal basis. Then we go for model training. I've told you that the exact accuracy of the model training is 90 point something, and test accuracy is 97.906. And out of the 11,796 images, 11,540 images, 543 images has been depicted. So this is the classification report. You can see F1 score, recall, precision, and total score. And then we go for the confusion matrix. I told you I can show you the confusion matrix, but it's a basically messy because the 200 classes are divided by 200 classes. There are no problematic. I can show you. Please don't judge it. You can see it. It is 200 class, 200 class. So I can't show you something like that. It doesn't have like a normal others. So this is it. The front end using what I have used here, the glassmorphic aesthetic picturing. It looks much better. So this is the project directory structure where model main API. I can show you this in VS Code 2. See. So I have used in the major normal basis. I have used VS Code for the front end and back end model application server, and Unicorn as a basic API server. Then we go for like if you want to know like for someone who is trying want to use my model, they can go through the GitHub repo how to dependency or what you want, how to run this basic amateur steps if you want to. Then we go for demo. So this is my UI UX. You can see. So let me I was just testing here. So let me drag and drop something better. So I've taken a Kingfisher. Very normal one. So let me go for like cardinal. Open. See, it's a very beautiful word. So let me check this. See, it's giving 91.1% a cardinal. So it's a correct. I've checked in internet. I've downloaded from internet. So this is the taxonomy. Why I did use the taxonomy, like the order, family, from which family does it belong, genesis, and this is where I use my Gemini 3.6 Flash. It will retrieve ecology. Yes, see, it has used Gemini 3.6 Flash. So this economy intelligence, this is the where I use Gemini 3.6 Flash, and one more there, like habitat where it is mostly found, geographical range, migration pattern, and something facts, interesting facts to be listening. Like I have also added something like this. Wait. So let me about this bird. Tell me about this bird migration pattern. So I will go for ask AI. So I've added some emojis like that, like his face pattern. See, sir. So he is giving like not cardinals are actually not migrating birds, so they don't migrate. It's actually there, but you can also like they can interact with the UI and UX. So let's go for another picture, like what is this albatross, and I downloaded from internet. See, sir, this bird. I think so it is seabird. So let's go for like fetch. Again, sir, we're using 3.6 Flash for retrieve ecology. Yes, sir. So again, sir, ecological intelligence, and come here. The 3.6 Flash makes it move, and that's it, sir. Thank you.